All right, so in our lesson, this is lesson actually 28, unit 4, but it says what are perfect squares? So in the equation, what expression could be substituted for a so that it's true for all values of x? So in here, we see that for a, if I want x squared equals a squared, I have to substitute a is equal to x. And then I would get x squared equals x squared. For number 2, if I have 3x in parentheses squared, and I want that to be the same as a, I have to put in a is equal to, in parentheses, 3x, or just a equals 3x. Either is fine. For number 3, 7x times 7x equals a squared. Well, if I multiply that out, I can see we have 7x all being squared. So then the base a is going to equal 7x. And then here, if I have 25x squared equals a squared, I could see that a is going to have to equal 5x, because if I take 5x and square it, 5 squared is 25 and x squared is x. For number 5, a squared equals 1/4 squared. Well, what number times itself is 1/4? That's actually a half, and then x. So a equals 1/2 x. And then here, if a squared equals x plus 1 squared, a is equal to x plus 1. And then this one seems a little bit more confusing, but if I write 2x plus 9 times 2x, or 2x minus 9 times 2x minus 9, that's the same as 2x minus 9 squared equals a squared. Or we could see that a is equal to 2x minus 9. So for our second task, each expression is written as a product of factors. Write it in factored form, or write it in standard form. So 3x squared, or 3x, the quantity squared, is really the same as 3x times 3x. So we can see that this is still in factored form because you have x times x. So to multiply that, multiply 3 times 3, 9, and x times x, x squared. So b, 7x times 7x, multiplying 7 times 7, 49, x times x is x squared. And then for c, x plus 4 times x plus 4, x times x is x squared. And then some of you do, well, x times 4 is going to be 4x, plus I can see another 4 times x, so it's going to make a total of 8x. Some of you show more work, so 4 times x, I would write plus 4x, and then plus another 4x, and then plus 4 times 4, so plus 16. So I need to combine my like terms, and we have x squared plus 8x plus 16. And then here, x plus 1 squared, that is x plus 1 times x plus 1. Or we would have x squared plus 1x plus 1x. So x squared, 1x plus 1x is plus 2x. And then plus 1 times 1 is 1. And then x minus 7 squared would be equal to x minus 7 times x minus 7. Or x times x is x squared. And then minus 7x and minus another 7x, so minus 14x. And then plus 49. And then for f, x plus n squared is x plus n times x plus n. Or to do that, x times x is x squared, and then plus nx, and then plus another nx, and then plus n times n is n squared. I have nx terms that are the same, so I need to combine those. So that makes x squared plus 2nx plus n squared. So here we're moving from factored form to standard form. And now for number 2, I'm going to have to work backwards. So this is in standard form, and I need to factor. So we have x squared and 9. And they ask why they should be perfect squares. Well, to make x squared, I know I have x times x. And then if I need perfect squares that make 9, it has to be 3 and 3. And just double checking that, we have 3x and 3x. Combining my x terms, 3x plus 3x makes 6x, so I did this correctly. The most common mistake, again, was seeing the factors of x and 3, that's x plus 3. And then here, another x plus 3. So in factored form, this is x plus 3 times x plus 3. Or to write this with a perfect square, we have x plus 3 squared. So since we have x plus 3 as our base squared, this is why this is a perfect square. Same idea here. We have x squared minus 16x plus 64. To factor that, we have x squared and then 64. So I know on the outside I'm going to have x and x. The square root of 64 is 8. However, I need my terms to add up to negative 16. So it can't just be positive 8. It's minus 8 on both. So my perfect square is x minus 8 times x minus 8. And I'm going to check the middle terms just to make sure. Negative 8x, negative 8x. And then in adding those, it's negative 16x. So in combining that, we would have x minus 8 squared. And then lastly, x squared plus 1/3 x plus 136. To do that, we have x squared and 1/36. Now this is actually a little bit more difficult. So I know I'm going to have to take the square root of 136. So I'm going to do that, square root of 1 over 36. And then to take the square root of a fraction, you take the square root of both pieces. So the square root of 1 over the square root of 36. Square root of 1 is 1. Square root of 36 is 6. So this ends up being 1/6 and 1/6. So in here I have 1/6 x and 1/6 x. To add my fraction, I have 1 over 6x plus 1 over 6x. Adding the numerators, 2 over 6. Or adding the numerators, 1 plus 1 is 2. Keep the denominator 6 and then x. I need to reduce 2 over 6x. So divide by 2 in the numerator and the denominator. 2 divided by 2 is 1. 6 divided by 2 is 3, so 1/3 x. So here, this would be x plus 1/6 times x plus 1/6, which would be x plus 1/6 squared. So here, for all of those are perfect squares. And then lastly, if we look at these task statements, how to solve x minus 6 squared equals 25, it looks like Han wrote x minus 6 squared as x minus 6 times x minus 6, then distributed and got x squared minus 12x plus 36, set that equal to 0 by subtracting 25 from both sides, factored x squared minus 12x plus 11, and got x minus 11 times x minus 1, use the zero product property to get x equals 11 and x equals 1. Now, his method seems like a lot of work compared to Jada's method. To do x minus 6 squared, she took the square root of 25, so that would be x minus 6 equals the square root of 25 would be plus or minus, because I could do plus or minus the square root of 25. So if I do that, x minus 6 is plus or minus 5. So we see here x minus 6 equals positive 5, and x minus 6 equals negative 5. So adding 6 to both sides, we see that 5 plus 6 is 11. And then add 6 over here, negative 5 plus 6 is 1. So using the same idea over here, if I have y minus 5 squared equals 49, I'm going to take the square root of both sides. So y minus 5 equals plus or minus the square root of 49 is 7. So I'm going to break that up into two equations. Y minus 5 equals 7. And y minus 5 equals negative 7. Adding 5 to both sides, I get y is equal to 7 plus 5 is 12. And then adding 5 to this side, y is going to equal negative 2. So we solved that one. I'm not going to solve all of these for you, but I'm going to do another example with decimals. So if I have y minus 0.1 squared equals 0.36, I'm going to take the square root of both sides. So y minus 0.1 equals plus or minus the square root of 0.36. Then I'm going to use a calculator for that. So the square root, and then of 0.36, and it's 0.6. So y minus 0.1 equals plus or minus 0.6. Then I'm going to break that up into two equations. Y minus 0.1 equals 0.6, and y minus 0.1 equals negative 0.6. So adding 1 to both sides, so adding 0.1, we get y is equal to 0.7. And then adding 0.1 to the other side, we get y is equal to negative 0.1.